So my name is Shankar. I'm the technical director for ActiveIQ, and I look at both our AI and data engineering initiatives. So I'm actually going to talk about two different things. In the first part, I'm going to talk about some of the machine learning workflows that we have in ActiveIQ. And then in the second part, I'm going to talk about how we architected the system as a whole. So this is the portion that we call the brain of ActiveIQ, right? It's what happens behind the scenes. So as Marty said, we've been getting telemetry data actually for the last 2 decades at least. And we've been doing some sort of predictive analytics for a very long time. I think we were one of the very early companies that had models to predict when a disk drive is going to go bad and then proactively replace that, right? So we get 4 pieces of information every single day from our storage controllers. One is the configuration of the system. The second is performance counters. And these performance counters have gotten more and more sophisticated over time. We get logs. These are equivalent to your FreeBSD or Linux logs, as well as what we call significant events. So for example, if we notice that a network card is getting a lot of errors over time, we can denote that as a significant event and say, I think this card's going to fail. And for any significant event that we get, we respond really fast, create a case or take whatever the appropriate action is. So we get these messages at least once a day from over 300,000 systems around the world. We can also trigger these on demand if necessary, right? So this comes in handy when you're trying to triage a support problem. And the last piece is then when something fails, whether that's software or hardware, we will do something in under 2 minutes. That's our SLA. We'll take some action. So this slide gives you a sense for the numbers that we're talking about. So 200 billion data points a day, or roughly about 10 trillion a month, because we get a lot more on the weekends. And 400 terabytes of telemetry processed per month. Now these numbers are doubling anywhere between 8 and 12 months, right? They're doubling really fast. And this poses a huge challenge for our back-end ecosystem. One, because we have to scale. And the other thing is, because we have to find space for all this data. And while we're a storage company, storage is definitely not free for us, right? So we have to find a way to maintain all of this. So we have some of this telemetry data sitting in a 4 petabyte hot data lake. This is what our data engineers and data scientists use for interactive analytics. And we maintain historical information about 15 petabytes worth. The important thing in this slide is that it's this vast amount of data that's what makes this machine learning and deep learning possible, right? You need to have a lot of data to do this. So what I'm going to talk about are 3 different sort of groups of workflows that are powered by AI. And when I say AI, it's a very broad catch-all term, includes what people call machine learning as well as deep learning. So let's first look at the face, or what's visible to customers. And I'm going to focus specifically on risks, right? So Sudeep and Marty spoke about risks. This is actually I'd say one of the most popular features in ActiveIQ, to understand what are some corrective actions you can take in your ecosystem. And we apply machine learning specifically to 3 parts of this. The first is the creation of the risk itself. So for many years, the way a risk got created is, somebody in support realized that there's this thing that's happening, causing cases to get created. And so a human essentially infers that, this situation is not good. Let's codify that as a rule, right? So that's how rules got created. But you can only get so far by doing it with human intervention. The thing we realized is there's a vast amount of information that's there in our docs online and even in our support forums. Especially in documentation, you'll see sentences that say, if option X is turned on, don't turn on option Y. Or if this variable is set to 500 milliseconds, then set this other thing this way, and so on. So we can apply natural language processing and extract these sentences. So that's the easy part. The hard part is converting that into a rule without any human intervention, right? So we have done that fairly successfully, and we've actually had a large number of rules get added as a result of that. Okay. The other two places we use machine learning, one is in what Sudeep spoke about, which is predicting how likely is it that you'll have a case if you don't fix a risk, right? It's a very useful thing for someone to know, because if you're presented with a large set of risks, you have to decide what are you going to work on first, or how important is it for you to fix something. And so if we tell you there's a very high probability you're going to have a disruptive event, odds are high you're going to do something about it. So we do this using a technique called associative rule mining. And so that's what feeds this feature. The last piece is making recommendations about upgrades. Telling you that if you upgrade, what are the odds that your risks will go away? And we do this with a fairly simple technique called clustering, right? So these are three specific use cases that you see today in ActiveIQ powered by machine learning. In addition, we use machine learning to do forecasting. When are you going to run out of space? Or something that's a little more complicated, which is when are you going to run out of performance headroom? Okay, so those are two places where we have it today. So that's what's there today.
For that,
Yep.
Did it fix it stuff? Not all of the last column, I can't read. Resolved after upgrade or whatever that is.
Right.
Is that something that the system determines, or that an end user says, yes, it fixed it? Not all risks are measurable, right?
Right. So no, so the end user doesn't say anything at all. So
Okay.
we look at past historical data, and we look at people that have done upgrades, and we understand what risks they had before and what they have after. And then using machine learning, we draw some inference, right?
Okay.
And then when the next person upgrades, so suppose someone got presented with this list and they did an upgrade, we would then retrain our algorithms too.
Right.
Yeah.
So, I mean, that seems easy for things like you're running out of storage space. Either you're still running out of storage space or you're not.
Right.
But I could foresee maybe you're not defining those other types of risks. I have to think more about what those might be, where it's more subjective and less objective.
It's a good point. So for certain things, so here's the thing. If you had a very few customers with risks ABC, right?
Yeah.
You can't infer anything useful.
Yeah.
You need a vast amount of data.
Yep.
Right? So for certain things like firmware updates and things like that, where a lot of customers will usually have that situation, it's easier to make good inferences.
Exactly.
Yeah.
So that's what I'm saying.
Yeah.
There's a certain type of practice or risk, whatever the rows are, that are easy to do that with more confidence. And then there are ones where I would think that last column.
That's right. So which is why we actually produce a confidence score, which says how confident. This is a demo thing, so it says 100.
I get it. Okay, so that makes me feel better about it.
Yeah.
Okay.
But it would say, like, if it didn't have confidence, it may say 20%, right?
Yeah,
You don't
exactly.
Really know. Yeah.
Exactly. Okay, thank you.
Okay. So I'm going to switch now and talk about some other things we do with machine learning in ActiveIQ, which are not visible on the face of ActiveIQ, right? So you won't see it in the UI, but it does impact the customer in the end. One of the most important ones is improving our models for part failures, okay? So we've become very good about predicting disk failures. In fact, we've written papers about this. It feeds the next versions of our operating system. That's really good. Now, with the increasing use of SSDs, right, we can build much more sophisticated models, because the ways in which SSDs fail are very different from the ways in which traditional disks fail. Right? And then you have host bus adapters, network cards, all kinds of things. So we're constantly using, deep learning is very effective in this space to improve the models that predict failures. The second place where we started using machine learning is to accurately size storage. Today, if you're a NetApp partner or you're a NetApp salesperson and someone comes to you and says, I need to accurately size storage for this particular workload, we have a tool that does that. And the way it used to work was we had engineers that would build handcrafted models using queuing theory. It was a very cumbersome process, took a lot of time, right? Not always perfect. What we have found is that when you have a sufficient amount of data, you can actually do a really good job with machine learning, and you can build much more effective sizers. Okay. The last one is a bot that we have in our support center. It's called Dexter. I mentioned the name because you can go online and there's a research paper that describes this. So this bot will wake up whenever it sees a case, and it'll go in and say, I believe this case is because of these top 3 reasons or these top 5 reasons, right? Does this using machine learning. And the way it does is it looks at all the past history of cases and all the telemetry data that was present before the case happened. And it draws some inferences about, which were the significant events that caused a case. So when it's right, of course, it's amazing, right? In literally a second, it'll tell you what the problem is.
Yeah, I'm sorry, going back to that accurate sizing of storage. So because you're using ML, AI, all of your prior history, does that mean it actually uses real data in terms of compression ratios and that sort of thing instead of optimal values or optimal guesses at what you would get?
That's right. And this is also a place where knowing the workloads is very important, tying to your earlier question, right? Yeah, so we look at everything. Yeah, the storage efficiency that you're getting, how much utilization you're having on the controller. And the data that feeds these models is not just the telemetry data we see from ActiveIQ. It's also the result of what happens in our internal performance engineering labs. So both of that feed into this. Yeah. And so if you know all your workloads accurately, right, you can make much better decisions here. Yeah.
Can it also take into account prior history for that particular customer?
It does. It does to a certain extent, because what we do is we look over a period of time and we average out the values. Yeah. So in that sense, we do look at history. Okay. Yeah. But if your question is, do we look at fluctuations of a workload over time? Not quite. Yeah. That'd be much harder to do. Yeah. Okay. So the last part is what we're working on now, what's coming soon. Some of the details of this we're going to save for the off-camera session. The first one is what we're calling advanced workload detection. So you asked a question about, do you let people tag your volumes? And we let you do that in ActiveIQ. And we have some number of customers that will do that. But what happens is, if you have a very large number of volumes, it can take a while for you to do all this. I mean, if you were very careful and every time you created a volume you did this, it's easier. But after the fact, it's harder. So what we do today in ActiveIQ is we look at those tags, and we also look at some heuristics like volume names and snapshot names. And so we can infer the workloads that you have. The hard part is when we have no information, right? How do we determine what workload's running? So for this, we're actually doing something really interesting that uses a combination of plotting some graphs and, strangely enough, image processing. And I'll describe this in our off-camera session. But it's turned out to be very effective in discovering what workloads are running. The second thing, which you also alluded to, is configurations. Now, if I know all the workloads that are running across the base, I can make very precise recommendations about what are the optimal configurations for a workload, right? What kind of storage should you use? What controller? What are the best options and things like that? Okay. The last part is what we call prescriptive ops. And I'm going to describe that in the next few slides. So let's start with what a typical storage admin does, right? And this is just one of the things a storage admin does. This is a 10,000-foot view of what happens. So why do you provision storage? Well, it's because somebody wanted to run an application, right? So an application team comes in and says, I'd like to run MongoDB, I need some space. Now, it's very rare for an application team to be precise about the IOPS they need, or the latency, or even how much space they need, because nobody really knows, right? Which is why you find storage systems are massively over-provisioned most of the time. And so now the admin has to make a provisioning decision based on this incomplete information, right? And how do they go about doing this? So it's really 3 things. One is they can look at documentation online. And for certain workloads, like for example, Oracle, there tends to be a lot of documentation. You can go to training classes. or the biggest differentiator about how someone does this well is experience, right? You just learn on the job. So you use this experience and documentation, and you make a provisioning decision, and then you have to monitor that provision storage to make sure it meets the application's needs. And so this cycle goes on, round and round. So what we did is we looked at the decisions that storage admins have made across our customer base. Very, very large number of customers, right? These 300,000 controllers. And we said, what are the outcomes they're getting? So if you look at any human endeavor in life, whether that's swimming or dancing or whatever it is, there's a bell curve. You have some people that are doing phenomenally well. You have some people that are struggling, and a very large average, right? We asked ourselves, is this phenomenon true here as well? And it turns out it's absolutely true, right?
Where on this curve is faking it?
Right before making it. Just struggling.
That whole graph.
Faking it.
We're all just trying to figure out as we get older.
Well, the good news is the curve is skewed towards the right, so it's not.
There are no X and Y labels, therefore the graph is suspect.
Or completely true. The graph is completely.
Well, again, off camera, I'll show you a graph with the latest. Yeah. But so we have done this. We looked at various storage. We created some metrics to measure the outcomes you're getting from storage, and did this analysis across all these metrics. And we found some admins, they were just getting absolutely phenomenal results. We've had some customers that have never seen a failure in like years, right? Remarkable. And there's this large average. So we asked ourselves the question, what can we do to move everybody to the right side? See, there's two other things that are going on that we believe adds to this phenomenon. One is, there's a lot of information in the world today, and people not very keen to read anything, right? So not everybody reads all the documentation that's out there. The second thing is there's this increasing move to getting IT generalists, right? Instead of very specialized admins. And so we believe that that's what's leading to this curve forming as well. What we felt we could do is use this ActiveIQ telemetry data combined with a few other things, and essentially move everybody to the right side of this curve. And again, we have actually done some of this, and we believe it is possible. So this is what we're calling prescriptive ops. It's the combination of telemetry data, a large amount of telemetry data, our documentation, and the community wisdom that we derive from this data, as well as the docs. So here's what I mean by that. If you think about this data we're getting back from these 300,000 systems every day, it represents two things. One is the actions that storage admins are making every single day, right? And the second thing is something we can infer with machine learning. What are the consequences of those actions? So for example, I might see today that 5,000 storage admins set a knob to true. A week later, I can infer using machine learning what was the consequence of that action. Did these storage controllers suddenly improve in performance? Or did they start to fail? Things of that sort. As a human, you'd never be able to tie these things together. But with machine learning, we can. Then what we can do is we can go look in our docs. Once we've tied these actions and causes, what we can do is we can go look at our documentation and say, what is the answer to this? How do we get people to be better? Now, what people typically do is say, here is an action you can take, and by the way, it's in this document. We want to go a step further. We actually want to give you a custom recipe, a piece of code that you can literally cut and paste and apply for yourself, right? And so we can do this again using various techniques. And because we know who sent us the telemetry message, we can actually customize that code for your environment.